denominator is the same. Okay, this is the standard form. Okay, the reason is then you can see the two components on it very easily. Okay, you can see the real part and you can see the imaginary part. Okay, that's why you kind of separate it out. Okay, so just to give you a heads up, I'm kind of picky about this. Okay, make sure you do not write it like this. All right. All right. Talk about graphing complex numbers. Okay. So give me a minute. Let me snip this guy. Snip. Oh, Neha shows up now, and she's got a slip. Oh, Neha was at home having lunch. All right, whatever. Yeah, she was having dal bhat. Was it dal bhat or was it paratha and chicken? Was it paratha and chicken, Neha? No paratha and chicken. Oh, that's no fun. Okay, so. No, I'm not kidding. I'm serious. Okay, this is the real axis. This is the imaginary axis. So if you've got a complex number of minus 4 plus 3i, then the way you graph that is you go negative 4 units in the real axis, okay, and you go positive 3 units in the imaginary axis. So your number ends up there. You then have a concept of the magnitude or the absolute value of a complex number. And that number will always be positive, will always be real. And it's going to be obtained by negative 4 squared plus 3 squared, which gives you 5. Does everybody see the connection between this and the triangle here? Everybody see the connection there? Sorry, Cindy? Pythagorean theorem? Maybe you guys need to go at Subway. I think that's where Cindy is getting all her... Yeah. Sorry? I should buy you all Subways? You should. I'm a poor teacher, man. You guys are loaded. You are the ones who drive BMWs. Who, I have a Lexus? A 20-year-old Lexus? 20 years old. Yeah. Yeah, that's a ghetto car. Yeah, I take my manure in that car. Okay? Does everybody see the connection between that and the Pythagorean theorem? Yes. Johanna? Yes? Yes? Okay? So everybody know how to graph a complex number? Yes. Yes, Cindy? I guess. Okay? So that's the same thing that I gave you earlier. Okay? We now come to the more important topic today. Okay? A completely new form. Whoa, what the? You know what the problem with this is that my scroll bar is too small, so I can't seem to grab it. This scroll thingy here. Oh my God. Sorry, Susie, can you say it loudly so it's recorded? Seriously, I want everybody to hear that and understand it. By now you should know, okay? I don't like LAs. Well, maybe I should have no SS. Get it? No sleeping at? Yeah, get it? Alright, so we are doing a new form of a complex number that's called a trig form or a polar form. Okay? Trig or polar form. And the process of getting this polar form is a little involved. It's not too hard. You obviously have to know your friends. I mean, yeah, not those friends, okay? You know what I'm talking about. Yeah, right, Shannon and Miss Wong, yeah. Not those friends, but the friends a la trig, okay? The friends a la trig. You shall appreciate the power of having these trig form of complex numbers when we do nasty things like this. That is disgusting. Yeah, that's X-rated stuff. Okay? But if you use the trig form of a complex number, this is easy. Okay, extremely easy. So there's a real importance for using the trig form of a complex number. So for the standard form, the two variables are a and b, as you can see in this form here, okay, in a plus bi. That's called the standard form. For the trig form, you've got two different variables, r and theta. And since they represent the same complex number, obviously there's got to be a connection between these two things. Okay? And so the connection is a equals r cosine theta, b equals r sine theta, and tangent theta is equal to b over a. Okay? These three things are also written in an alternative way. Okay? They're also written as r equals square root of a squared plus b squared, or theta is equal to tangent inverse b over a. Please note that this tangent inverse is not a reciprocal. It doesn't mean you flip b over a. It means you find the inverse of that to get an angle. To get an angle. Okay? All right, so there are connections between AB and R and theta. And we're going to use this concept in going from a number in standard form into trig or polar form. Okay? Do you want me to pause here for a minute so you catch up? So let's go find the recipe for going from a standard form to trig or polar form. So